Yo, all right, here we go. We're going to start talking about average rates of change in calculus. This is where it starts to get real good. So, rates of change. We encounter rates of change all the time. And you've heard things like miles per hour, or with weather, maybe inches of rainfall per year, or populations, the percentage of increase per month, per year, per day. These are all average rates of change, where you have a change in some functional value and then it's per the length of interval or usually elapsed time, so to speak. So, all right, so how do you do it with functions? Like if I have y equals f of x and I want to find the average rate of change of this function over the interval a, b, how would I do that? Well, it turns out it's pretty easy, and you probably learned this in Algebra 1, right? And it's just slope of the line, right? And specifically, we'll call this a secant line. So a secant line is just going to be a line that intersects the curve at more than one point, these 2 points here. And if I find the slope of this line right here, it's actually going to give me, or represent, I should say, the average rate of change of this function over this interval. So now you'll notice I have three pictures and they all basically look identical. I'm just labeling that second x value differently, and that's just to give you a different feel of how you might see it. But they're all going to mean the same thing. So here we go. Let's represent the average rate of change of y equals f of x over the interval a, b. Well, first off, you got to get the y values, right? So if this is y equals f of x, and this is the x value or the input a, then the output or the y value would be f of that. So it'd be f of a. Likewise here, if this is the x value b or the input b, then the output here, the y value, would be f of that. It'd be f of b. So now to represent the slope of this red line here, you did this back in the day, it's change in y over change in x, right? So it's going to simply be f of b minus f of a, that's change in y, over b minus a. And right there we have a formula for the slope of a secant line, but it also now has meaning to us. So I'm basically telling you this is representing average rate of change over the interval AB, right? And it's important to notice that average rate of change is going to be over an interval. All right, so now let's take a look at this one. Why is this different? Well, maybe I come along and say, you know what, instead of calling this x value b like I did here, I'm just going to call it x because maybe I want people to know that I can vary it, right? So what changes? Well, first off, that means the y value here at this point would be f of that, so it'd be f of x. So now when I go to find the slope of this secant line, or the average rate of change, it's going to be change in y. So f of x minus f of a over x minus a. So not much change, right? Just the value here of how I label this. So now this slope of the secant line, again, represents average rate of change over the interval now a to x. It's just a different way of seeing the same thing. It's just based off how you label it. Another common labeling of this type of diagram would be that what we have here. So if this is A, and I say, you know what, H is some positive value, then it would make sense that A plus that positive value would be somewhere to the right of A. So we'll call this A plus H. Right now I could make H negative, it just means it would be over here. But in this particular picture, A is drawn as if it's positive. So now if this input, if this x value is a plus h, then the y value here would be f of that. So it'd be f of a plus h. So when I go to find the slope of this secant line now, it's going to be f of a plus h minus f of a, that's change in y values, over change in x values. So a plus h minus a. But in this particular problem, what didn't happen in these two, what happens here is that I can spruce this, right? Because these a's are going to sum to 0, right? They cancel, so to speak. And so now I'm going to get, when I rewrite this, f of a plus h minus f of a all over h. And this still represents, a little better h here, this still represents average rate of change. But now this is average rate of change over what interval? A to a plus h. These things are oftentimes in calculus referred to as difference quotients, right? Quotient meaning divide, difference meaning subtraction, right? So even though you don't see the subtraction in this one, in the simplified version, like, oh, that's just h. We have to realize it's coming from a plus h minus a. So these are all difference quotients. They all represent slopes of lines, in particular slopes of secant lines over an interval. And now I'm telling you that they actually represent the average rate of change of that function. All right, so let's see how this plays out in some problems. Here's a straight, boring, cheesy, mathy one, right? So straight up saying, hey, find the average rate of change of this function over this interval. So you're like, all right, I have a formula for that, right? So the average rate of change is just the slope of the secant line. And since I'm finding it over this interval, this is like my A and this is like my B in those previous pictures. So it'd be change in the Y values. So f of 3 minus f of 1 all over change in the x values, which would be 3 minus 1. That represents the average rate of change of this function over that interval. And this we can actually compute more, right? So f of 3 would be 3 squared, which is 9, plus 1, which is 10, minus f of 1, which is 1 squared, which is going to be 1 plus 1, which is 2. And then 3 minus 1 is 2. And then 8 over 2 is going to be 4. So I get 4. But maybe I'm just, for emphasis for this time, going to write this as 4 over 1. Now, what does this mean? This means that on average, over this interval, this function is going to increase 4 y units for every 1 x unit. All right, because remember, these are y values, these are x values. Now, let's just take a look at the graph here. I'm going to do a real rough sketch of what this thing looks like. And maybe not even the perfect scale. All right, so let's change the pen color. So maybe, let's see, x squared plus 1. We all know that's a parabola shifted up 1. I'm going to flatten it out a little bit so my secant line looks decent. And so I'm looking at the average rate of change of this function over the interval 1, 2, 3, right? So here's the point at x equals 1. So its y value would be f of 1, which we did, by the way, and we got 2. But maybe I'll just write it as f of 1 for now. Here is the point corresponding to the input of 3. That y value, we got 10, but I'm going to write it as f of 3. And now I'm going to do my best here to draw a secant line. You can label it secant line. And basically what we did is we found the slope of that line, right? So it was up 4 over 1. So what we're saying is the red curve on average over this interval is increasing up 4 over 1. It's almost like the speed of the line, so to speak, right? Or the rate of change of the line. All right, but that's the average rate of change, and it's over this interval. All right, let's go to the next question. Next question is a multiple choice question. Pretty good questions. We ripped this off of some AP review. All right, so here we go. It says, let f be the function defined by f of x equals e to the 2x. And then here we go. The average rate of change of f over the interval 1b is 20. So now it's telling you that the average rate of change is 20. Now it says where b is greater than 1. Now, what's that nonsense all about? Well, if the interval is 1 to b, they're saying b is greater than 1 so that we know b is somewhere to the right of 1, right? Not 100% necessary, but that's how it is for this problem. So now it says, which of the following is an equation that can be used to find the value of b? So this is kind of like somewhat of an application problem, right? So you see the words average rate of change, and that should immediately make you think difference quotient, right? And since my interval is 1b, then it would be f of b minus f of 1 over b minus 1, right? And this right here, this difference quotient, is going to represent the average rate of change of this function over the interval 1b. Now they're telling us is 20. So you just get e equals 20. And that's all you had to do. It said, which of the following is an equation that can be used for? Well, we just found the equation. It's this, right? So that's choice C, right? Choice D, there's a plus sign in it. There's a weird 2 down there. And this is just no bueno. All right, so now you're like, well, what if I had to find b? Well, then that would have been a little bit more challenging, but you could do it, right? You'd have to do f of b, so chuck b in here, get e to the 2b minus chuck 1 and e squared over b minus 1, maybe cross multiply, solve it algebraically if you could. If you couldn't, which I don't think we'd be able to, you could solve it with your calculator. But regardless, we weren't asking you to do that. We just wanted you to set up an equation using what you know about average rate of change. All right, let's take a look at 3. Last one. It says, experimental biologists often want to know the rates at which populations grow under controlled laboratory conditions. The figure below shows how the number of fruit flies grew in a controlled 50-day experiment. So you got to love these real life problems with fruit flies, okay? So maybe this is a little petri dish and you got a bunch of fruit flies in here, right? And as time goes on, they start to multiply, and you get more and more and more. So the number of fruit flies initially is going to grow exponentially. But then you get to that point and you're like, all right, the dish is only so big, right? It's not going to be able to support this type of increase. So they're still going to increase, but what happens to the increase? It starts to level off. This is actually called a logistics curve, where initially you have this exponential growth, but then it starts to level off. It's still increasing, just not as rapidly. So now the question said, find the average rate of change. So again, you see those words and you are thinking slope of a secant line. As soon as you see those words, from day 23 to day 45. Now I labeled the points for you here, so you're seeing it a little bit different graphically, but it's the same picture that we started off with, right? This x value here is 23. Really, I should say maybe t value for time. This x value here is 45, right? This value here, it'd be f of 23, which, all right, they're telling you that's 150. And this f value, y, whatever you want to call it, y value here is going to be f of 45. Well, they told you that's 340, right? So, okay. Find the average rate of change in y's. So that's going to be 340 minus 150 over change in t's or change in x's, right? 45 minus 23. So let's see, 340 minus 150 is, I hope to God, 190. 45 minus 23, 22. All right, go ahead and chuck that in your calculator if you want. If you do that, you get 8.636. Remember, we always want to be accurate to 3 decimals in this class, and that's going to be your average rate of change. Now, what does that mean, right? So you got to give units to this thing, and it's always going to be y unit per x unit. But now there's meaning to these things, right? The y unit is number of flies. So this is going to mean number of flies per the x unit, or the t unit, is days. So what we're saying is that from day 23 to day 45, on average, right? On average, the number of fruit flies is increasing by about 8, right? 8.6 flies per day. So for every day, I can expect an increase of about 8 to 9 flies. Now, we know that it's not constant like that because it's not a straight line. The curve isn't this line, right? The curve is the curve. But we're saying this is the average rate of change over that interval from day 23 to day 45. So now B is kind of a silly question. We used to give B because I wasn't as straightforward as I was in the beginning of this lesson. It says find the slope of the secant line. You should be like, that's what we just did, right? So, C above. And this was just to drive home the fact that average rate of change is just slope of a secant line. That's it. Again, that's an Algebra 1 concept. So that's the takeaway to that. To find the average rate of change, it's just going to be the slope of the secant line. And maybe another takeaway is the 3 ways that we can common ways that we can represent it. F of b minus f of a over b minus a, but you can also represent it as f of x minus f of a over x minus a. You can also represent it as this one, which looks weird because you don't see the subtraction in the denominator because of that simplification, right? So that's average rate of change. Good stuff. Next video is going to be on instantaneous rate of change, which is awesome. So I'm sure you can't wait to watch it.